Okay, now section 5.3 is continuing what we've been doing, and we're going to define some functions. So you will need your unit circle handout for this video. We're going to complete that. So I'd like you to look at this little diagram right here. And we have 6 special functions for every point x, y of a circle graphed on a coordinate grid. So any circle that we have graphed right here. Okay, there's whatever, how, I'm not sure how big this isn't the unit circle, but all these points on the circle, every point on that circle, there's a function for each of those points. There's 6, and we're going to be doing the first 2. And the first one is called the cosine function, and the second one is the sine function. Now, a function is you have an input and an output. So if I input the angle, so suppose I input 80 degrees, then the cosine of 80 degrees is the output, and that is the x coordinate right there to get to this point right here. So this is the x coordinate, so the length from the x, and then this is the y coordinate, which is how high up on the y-axis. So the cosine is the x coordinate of however big that circle is, and the sine of 80 degrees, so if you input 80 degrees, the output is the y coordinate. Okay, and those are the functions. So you have to take the x coordinate and divide it by the radius. Okay, because I'm sorry, I was thinking we were on the unit circle, but suppose the radius is a great big circle, and say the radius is 10, and you have to take this length, the x coordinate, and divide it by the radius, which is however big the radius is on this circle. Okay, so that is this definition right here. So the cosine is the x divided by the radius. And if you look at this picture, it's the x divided by the radius. And I'm going to go for a little bit lighter here. Okay, so this x coordinate divided by this radius, and that value is the output. And if you wanted the sine function, you would take the y coordinate and divide it by the radius. Okay, so if we're on the unit circle, since it's centered at the origin, since the radius is 1, then the cosine is, oops, I think I'll do, it's easier to read. The cosine of whatever angle you give is the x coordinate divided by the radius, but since the radius is 1, then it's just x divided by 1, or x. And the sine is y divided by the radius, but since the radius is 1, you just get the y. So on this point, if this is the unit circle right here, then this point right here would be 1, 0. And this point right here is xy. Well, the cosine of that angle is the x coordinate, or this distance. And that's the cosine. And that's abbreviated cos, and pronounced cos, not cos. And the sine would be the y coordinate, and that's sine, that's abbreviated sin, that's not sin, that's pronounced sine, even though it just says it's not phonetically correct. And that would just be the y coordinate because the radius is 1. Okay, so on the unit circle, ordered pairs, x for cosine, y for sine, represent every point on the unit circle. So on your unit circle, we're going to put in the ordered pairs for the quadrant angles, which are multiples of 90 degrees. Okay, so this is a little version of yours. So this point right here is 1, 0, that's at 0 degrees. 90 degrees is 0, 1. And 180 degrees is negative 1, 0. And then 270 degrees would be 0, negative 1. Now, what I need to do is find the cosine of pi over 2. So you go to pi over 2, which is straight up right here. pi over 2. And the cosine is the x-coordinate. So the cosine of pi over 2 is 0 because that's the x-coordinate. And let's find the sine of pi over 2. Well, that's the same place, only it's going to be the y-coordinate. So that's 1. And the cosine of pi, let's look over here at pi. The cosine is the x-coordinate, which is -1. And the sine of pi is the y-coordinate, which is 0. And so that's how it works. To find the sine on the unit circle, the x-coordinate is the cosine or cos, and the y-coordinate is the sine or sine. Okay, now let's see. Here's what we have to do. The problem it seems like a problem. We have to find the coordinates of all these points. All these 3 and these 3 and these 3 and these 3. And not only do we have to find them, you need to memorize those. Okay, so these are easy ones because they're in the quadrants. You can almost just close your eyes and see them. But we want to get the quadrants of all those other ones. So there's a little way we do that. So we're just going to look at quadrant 1 first. Okay, in quadrant 1, let's get yellow. Okay, so in quadrant 1, we can see 3 triangles, and I'm going to draw those for you. The first one is a 45 degree, 90 degree. So if I take that pi over 4 and I draw that straight down to the x-axis, this is the x and y axis, quadrant 1, and I look at this triangle right here, right there, pi over 4 is at 45 degrees, and this is 90, and so you know there's 180 degrees in every triangle, so that leaves me with 45 degrees up here. And that's called a special triangle. That's actually an isosceles right triangle. And then the other 2 triangles are actually the same triangle, but let's look at this pi over 3 right here. And if I drop that straight down to a 90 degree, then I have this, because pi over 3 is 60 degrees, that's right here. And then this guy up here would have to be 30 degrees. And that's a 60, 30, 90 triangle. And then if I did this one, pi over 6, and I bring that straight down, then I have my right angle here. This is my 30 degrees. That means this one's 60 degrees. You can see that these two are the same triangle, rotated and reflected. Okay, but these are, so we're just going to use 2 special triangles, the 45, 45, 90, and the 60, 30, 90. Okay, and we're going to use the Pythagorean theorem to find the missing side lengths, because the x-coordinate will be here, and the y-coordinate will be here, and then this x-coordinate and y-coordinate will be the same because that's an isosceles triangle. And then these guys actually will be the same as these 2 up here, because this is these two numbers are the same. Anyway, they'll be switched. Okay, so let's find out what those are. All right, so here we have the 45, 45, 90 degree triangle. We're going to use the Pythagorean theorem, which is x squared plus y squared equals, I should say a squared plus b squared equals c squared. So let me do it that way. I think you might have learned it that way. So if I had a squared plus b squared equals c squared, only we're going to use, since they're both equal, we're going to, a is going to be x, and so is b, because they're the same. And c is going to be on the unit circle, so that's 1. Okay, if you go back up here, remember that the radius, all of these are 1 unit on this length right here, are all 1. Okay, so if I have 1x squared plus 1x squared, I add those together, that gives me 2x squareds, and 1 squared is 1. If I divide both sides by 2, I get x squared equals 1/2. And then if I square root both sides, I get x equals plus or minus the square root of 1/2, which is the square root of 1 over the square root of 2, which is the square root of 1 is 1 over the square root of 2. And then I'm going to rationalize that denominator, multiply by the square root of 2 over the square root of 2. So I get the square root of 2 over the square root of 4, or 2. So this side is radical 2 over 2, or root 2 over 2, whichever you like to say. And those are the two values for my pi over 4. The x length is radical 2 over 2, and the y length is radical 2 over 2, because that was this triangle. Okay? So one more time, we went to the 45, 45, and we got the length. Let's look at the other triangle. Now we're going back to these two. So here's one of them, pi over 6, where the 30 degrees is here. And then here's the other one where the 30 degrees is up here and it's 60 degrees. So those two triangles are the same triangle. All right. And this looks a little messy to me. Let's see. So let's just write on top of this. We know that this is 1. This is our radius. I don't know what that was looking like. It looks like I goofed on here. So I'm going to, let's go with, I wonder if your paper has this goof or it's just my computer. But right here, this is 1, because that's the radius. That's this radius on the unit circle. And this is, if we take this triangle and make bring that straight down, then we would have 1, 1, 1 equilateral triangle. And that means that this small distance right here is 1/2. And that's what this distance is right here, is 1/2. It's half of a whole equilateral triangle. If this is 1, this would be 1, this would be 1. Okay, so this is going to be our missing piece. All right, so let me take this messy thing and do it again, okay? So we have 1/2, 1 whole, and this is what we're trying to find. I'm just going to call it x. Okay, so we have our x squared plus 1/2 squared equals 1 squared. So x squared plus 1/2 times 1/2 is 1/4 equals 1, and then we'll minus 1/4, and we'll get x squared equals 3/4. So if we take the square root, we'll get plus or minus the square root of 3/4, which is the square root of 3 over the square root of 4, or the square root of 3 over 2. Now notice I took the positive value on this because we are talking about a length. It will be negative sometimes when we go back to our unit circle. All right, so that gives us the square root of 3 over 2 is the missing length here. So what does that help us with? Well, let's go to this. We're going to go to the unit circle and fill in the sines and cosines. Okay, and we'll go back to this. That gives us, instead of xy here, this long side, which is the x, is the square root of 3 over 2 we just found, and the short side is the 1/2. So this is the 1/2, this is the square root of 3 over 2. Just like these were both radical 2 over 2's. And then this one, the short side is 1/2, and this is the square root of 3 over 2. So this point is going to be, the x is the short, which is 1/2, and the y is the radical 3 over 2. Okay, and so we're going to end the video right here, and then finish on the next video.